Today we're going to look at 10-5, adding and subtracting rational expressions with unlike denominators. Alright, so we'll start with something pretty easy. First let's look at, remember when we were adding fractions? Say I have 1/3 and 2/5. Okay, when I add 1/3 plus 2/5, in order to add a fraction with an unlike denominator, what I need to do is get my denominator to be the same. I need to have a common denominator. So the least common multiple between 3 and 5 is 15. So in order to make 3 become a 15, I would have to multiply it by a 5. So if I do that to the denominator, I have to do that to the numerator, so I'm not changing the value of that fraction. So now what I'm going to have is 5/15. In order to get this one, I'm going to have to multiply it by 3/3. And now I have 6/15. Now remember, this is just a fancy 1. So each time I'm not changing the value of the fraction, I'm just renaming it by using the identity property. So we're going to do the same thing with variables. Okay. The common denominator between all three fractions would be a 10. The first fraction already has a 10 as a denominator, so I'm going to leave that one alone. The second one, I'm going to need to multiply it by a fancy fraction of 1, such as 2/2. Okay, so I'm going to get in there, multiply it by 2/2, and then the third fraction, I'm going to need to multiply it by 10/10. You could have a 10 in the denominator. So now what we have is everything's all over 10. So I've got x minus 2 times the quantity of 2x plus 3. 2 is getting multiplied by the entire binomial, plus 4 times the quantity, 10. So now I can write it all over the same denominator and just distribute and simplify the numerator. So now I distribute in my -2, and I have, and then I simplify it down. X minus 4x makes 3x, -6 plus 40 makes 36, and there's nothing I can factor out of the numerator, and there's nothing I can cancel from numerator to denominator. I can't divide out a common factor that way either. So now what I'm left with is -3x plus 34. Now remember, unless the binomial looks exactly the same, I can't divide a piece of it out. Alright, so looking for common denominators. If these were two fractions, pretend I was just adding these. What would the common denominator be? Or actually, they want the least common. The smallest possible denominator that I could divide both out of would be 4x. Now, I'm going to sidebar on this one, and I'm actually going to go to a blank screen. Let's see, let's do... Okay. Erase this. If I have an x squared and a 6x, when we're looking for the least common multiple, which is basically the same as the least common denominator, what I need to know are what are the factors of each term. So this one is made up of an x times an x. And this one, if I broke it down, I'm going to break it down including into prime factors, or it's like a 6, I guess I don't have to, let's do 6 times x, let's break down that 6 to prime factors, 2 times 3. So x times x are the factors for x squared. 2 times 3 times x are the factors for 6x. To find the least common multiple, I take the match, wherever there's a match. So I have x and x. And I use that once. And then I multiply everything else times the x times 2 times 3, and what my LCM is 6x squared. Okay? So again, we take the matches and everything else. Now, why don't you pause the recording and see if you can find the least common multiples for number 3. Actually, let's just stop at number 3. Now check your work. Numerically, the least common multiple would be a 12. And with the variables, it would be x to the third. That means 4x to the third would divide evenly into 12x to the third, and 3x would divide evenly. Another thing that you can do is you can just multiply your factors in the denominator to get a least common. Sometimes it turns out to be a common, not a least common. Number 4 would be x plus 2 times x minus 2. Number 5, let's pause the recording and have you do 5 and 6. Now check your work. Number 5 is y plus 4 times the quantity of 2 times the quantity of y minus 3. All 3 factors. Number 6 would be 3x times the quantity of x plus 2. X plus 3, sorry. All right, now we're ready to start working. So the first thing we need to look at is what is the common factor? It's 12. So what is the first fraction missing that would make the 2 become a 12 in the denominator? A 6. So if I multiply the denominator by 6, I have to multiply the numerator. And the second fraction, to make the 3 become a 12, I'd have to multiply it by 4. If I do that to the denominator, I have to do that to the numerator as well. Now I'm ready to combine all my numerators and put them all over 12. 3x times 6 is 18x plus 4x minus 5x. Combine my numerators, I get 22x minus 5x is 17x all over 12. Final answer. Nothing can be factored out. Okay, next one. We've got some variables. Again, our least common multiple, or our least common denominator, would be 10x. So I would have to multiply 3 over 2x by 5 over 5. Now I get 15 over 10x minus 2x plus 1 over 10x. Combine my numerators. Remember, when I have that binomial there, I'm going to have to distribute that negative into that entire binomial. So I get 15 minus the quantity of 2x plus 1 all over 10x, which becomes 15 minus 2x minus 1 over 10x. I combine any like terms, I get 15 minus 1 is 14 minus 2x. And now I have to see if I can factor anything. The numerator can be factored. I can divide out a 2, and so I get 7 minus 2x times 2 over 10x. Now I can divide out from numerator to denominator a common factor of 2. Take the 2 out of the top and 2 out of the bottom. I'm left with 5x in the denominator and 7 minus x in the numerator. Take a minute. Pause the recording if you need to look at this longer. Alright, so now this is kind of tricky for some kids to understand. Remember, a plus 3 is just a number. It's a fancy number. It's a factor. It's its own being. You can't take part of it. So a, I'm not just missing a 3. I'm actually, from the first fraction, over here, I'm missing an a all by itself. And from the second fraction, I'm missing a binomial called a plus 3. So the least common denominator would be a times the quantity of a plus 3. So of course, if I need to add the a to my first fraction, I have to do it on the numerator and denominator. I'm going to multiply it by a over a. And I'm multiplying the second fraction by a plus 3 over a plus 3. Now we've got 9a plus a plus 3 all over a times the quantity of a plus 3. Combine my numerator, like terms, 10a plus 3, and there is no factoring or any more simplifying I can do. So there's no binomial in the denominator that looks like 10a plus 3. Final answer. Now in the first one, to really figure out what I'm missing in each fraction, I have to make sure I'm factor. So x squared minus 4 is really x plus 2 times x minus 2. So what I'm missing here, let me write it out. In that x plus 2, what I'm really missing is x plus 2 times x minus 2. So in the first fraction, I'm missing an x minus 2 times x minus 2. So if I'm going to multiply it by the denominator, I have to multiply it by the numerator as well. So now what we get is x times x minus 2 minus 8 all over x minus 2 times x plus 2. We get, simplify, is x squared minus 2x minus 8 all over x plus 2 times x minus 2. Alright, I can do my x marks a spot, what multiplies to negative 8 and adds to negative 2. How about 6? No. 4 and 2. So what multiplies to negative 8? 4 and 2. Yep. 4 and a 2. And that would have to leave that negative and that positive. So my numerator becomes x plus 2 times x minus 4 all over x plus 2 times x minus 2. Final answer is this right here, x minus 4 over x minus 2. Now remember, I cannot divide out a piece of a binomial, so I can't cancel out those x's. Okay? I can only divide a binomial by another binomial. That's what equals 1. Pause the recording if you need to look at this further. Alright, pause the recording and see if you can do the next one on your own. Now check your work. Multiply the first fraction by x over x, the second fraction by x plus 3 over x plus 3. Combine my numerators all over one denominator, and then distribute the negative 6x x 6 into the x plus 3 and the positive x into the x plus 4. X squared, x times x is x squared, x times 4 is 4x, negative 6 times x is negative 6x over negative 18. Keep the denominator unfactored. I don't have to combine anything, so I want to keep it in that factored form because in the end I'm going to have to simplify. My numerator, is there anything that, how do we know that's unfactorable? Remember, what multiplies to negative 18 and adds to negative 2? Any of the factors of 18, 1 and 18, 2 and 9, 3 and 6, none of them add or subtract to 2. So that's where we know we have to stop. There's no more simplifying that we can do. And x squared plus 2x minus 18 all over x times the quantity of x plus 3 is our final answer. All right. So start this one on your own. Factor the denominators and then begin. Now check your work. Should have factored out a 5 in the first one and a 5x in the second one. Now I notice what I'm missing is an x over x in the first fraction, and then it looks exactly like the second denominator. So what we get is x squared minus x plus 2 all over 5x minus times the quantity of x minus 2. Distribute our negative in there. So I get x squared minus x plus 2 all over 5x times the quantity of x minus 2. Use your x marks the spot to factor it. X plus 1, x minus 2 multiplies to negative 2 and adds to negative 1, positive 1 and negative 2. And now we can factor out our x minus 2, and we are left with x plus 1 over 5x. Pause the recording if you need to continue looking at the notes. That's our lesson for adding and subtracting rational expressions with unlike denominators.